Hello everyone, this is Medha Jinur and today we will be learning about operators in C language. Now what are operators? They are the symbols that represent operations to be performed on one or more operands. Now C language provides a wide range of operators which can be classified based on their functionality. Now here is a simple example. C is equal to A plus B, where plus is the addition operator and A and B are the operands. Now, types of operators. There are 7 different types of operators. Arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, bitwise operators, and conditional operator. First, arithmetic operators. An arithmetic operator performs mathematical operations such as addition, subtraction, multiplication, division, etc. on numerical values. Now these numerical values can be either constants or variables. Now there are 5 arithmetic operators: plus for addition, minus for subtraction, asterisk for multiplication, slash for division, and percentage for modulo, or the remainder that you get after division. Now let us see an example. Now for arithmetic operators, here we have taken 3 variables. A is 9, B is 5, and C to store the result. So let us run and see. So as you can see here, the addition of A and B, that is 9 plus 5, will give 14. Subtraction, 9 minus 5 gives 4. Multiplication, 9 into 5 gives 45. Division, which gives the quotient. So 9 divided by 5 will be 1 point something. Since this is percentage %d, that is the format specified for integer, it gives only the integer value, that is 1. And the remainder after division will be 4. Now the second type, that is relational operators. A relational operator checks the relationship between two operands. If the relation is true, it returns 1. If the relation is false, it returns 0. Now hence, relational operators can be used in decision making and loops. So as you can see, there are 6 types of relational operators: equal to, greater than, less than, not equal to, greater than or equal to, and less than or equal to. Let us see an example for this one. Here for the example of relational operators, we are considering 3 variables for better understanding of all the cases. Let us run this first and cross-check. Here, first, 5 is equal to 5 is true, so it returns 1. 5 is equal to 10 is false, so it's 0. 5 greater than 5, false, hence 0. 5 greater than 10, again false, so 0. 5 less than 5, false, so 0. 5 less than 10 is true, hence 1. 5 not equal to 5. Now this is false, so it gives 0. 5 not equal to 10 is true, so it gives 1. 5 greater than or equal to 5 is true, hence 1. 5 greater than or equal to 10 is false, hence 0. 5 less than or equal to 5 is true, hence 1. 5 less than or equal to 10 is true, hence 1. Third type, logical operators. Now an expression containing logical operator returns either 0, 1, 1 depending upon whether the expression results in true or false. Logical operators are commonly used in decision making in C programming. There are 3 types of logical operators. Logical AND. Now if it's true, only if all the operands are true. Logical OR, either this or that. So it gives true if either one of the operand is true. Logical NOT. True only if the operand is 0. Let us now see an example for logical operators. Here A is 5, B is 5 and C is 10. First one, if 5 equal to 5, which is true, and 10 greater than 5, which is also true. So both the conditions are true, so the result is 1. Next, 5 is equal to 5, true, and 10 less than 5 is false. One true and one false, hence it is false. So result is 0. Third one, 5 is equal to 5 is true, or 10 less than 5 is false. Now one is true and the other is false, hence the result is true, so it is 1. Next, 5 is not equal to 5, which is false, and 10 is less than 5, which is also false. Both the conditions are false, hence it is false, so you get 0. Now 5 not equal to 5, false. Not of false is true, hence you get 1. Next, a 5 is equal to 5, true. Not of true is false, hence result is 0. Next type, assignment operators. An assignment operator is used for assigning a value to a variable. Now there are 6 types of assignment operators. Is equal to is the most common type of assignment operator. A is equal to B. Then plus is equal to, which means A is equal to A plus B. The next one, A minus is equal to B, which means A is equal to A minus B. Similarly, applies for multiplication, division and modulus also. Now this is an example for assignment operators. We take one variable A is equal to 5. Now here, first one, C is equal to A, which gives what? A value is stored in C, therefore C is 5. Next, C plus is equal to A. The value of C is 5. So this means C is equal to C plus A. 5 plus A, that is 5, will give 10. So now C has the value 10. Next, C minus is equal to A, which means C is equal to C minus A. So C is equal to 10 minus 5, which is again 5. Next, C asterisk is equal to A. So which means C is equal to C into A. C is what? 5. 5 into A, that is 5. 5 into 5 is 25. Moving on. C slash is equal to A, which is C is equal to C slash A. So 25 divided by 5, quotient is 5. Next, C modulus is equal to A, which is C is equal to C modulus A. Now 5 modulus 5. 5 divided by 5, quotient is 1, remainder is 0. So C is 0. Now let us cross check. So we have got the same values. So this is done. Now increment and decrement operators. Increment operator plus plus increases the value of a variable by 1, and decrement operator minus minus decreases the value of a variable by 1. Now there are 2 types, prefix and postfix. Now in prefix, like plus plus variable, the value is incremented by 1 and then it returns the value. If we use postfix operator, variable plus plus, it first returns the value of the original variable and then it is incremented by 1. Similarly for decrement also, prefix minus minus variable. So it first decrements the value by 1 and then it returns the value. Postfix, variable minus minus. So first it returns the value of the variable, then it decrements by 1. Example for increment and decrement operators. Here we have taken 2 variables, Variable 1 as 5 and variable 2 as 4. Now first, variable 1 plus plus. So variable 1 is printed first. So what does it print? It prints 5. Then it increments. So the value in the memory will be 6. Moving on. Plus variable 1. So first the value is incremented. So what is the value? 6. 6 plus 1 will be 7. Then it prints. What does it print? 7. Next, variable 2 minus minus. So first it prints the value. What is the value of variable 2? 4. Then it decrements. So it becomes 3. Now, minus variable 2. So first the value is decremented by 1. So 3 becomes 2. Then it is printed. So what is printed? 2. So these are the values that it prints. 5, 7, 4, 2. Next, bitwise operators. Now in the arithmetic logic unit, mathematical operations are done in bit level. To perform these bit level operations C programming, we need bitwise operators. As you can see, there are 6 types of bitwise operators: bitwise AND, bitwise OR, bitwise XOR, bitwise complement, left shift and right shift. Let us go in detail. Bitwise AND operator. Now the output of bitwise AND operator is 1 only if the corresponding bits of the two operands is 1. In all the other cases it is 0. Let us take an example of 12 and 25. This is the binary value of the respective numbers. AND operation. So 0, 1 will give 0, 0, 0 is 0, 1, 0 is 0. Only 1 and 1 will give 1. Rest all cases it is 0. So 0, 1 is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, which is equal to 8 in decimal. Next, we go to the bitwise OR operator. Now the output of bitwise OR is 1 if at least one corresponding bit of two operands is 1. So for the same example, we do the bitwise OR operation. So 0, 1 will be 1, 0, 0 is 0, 1, 0 is 1, 1, 1 is 1, 0, 1 is 1, 0, 0 is 0, and so on, which is equal to 29 in decimal. For bitwise AND operator, both the corresponding bits should be 1. Only then it will result in 1. Rest all cases 0. In bitwise OR operator, either 1 or more corresponding bits. If it is equal to 1, then the result will be 1, or else it is 0. Moving on. Bitwise XOR or exclusive OR operator. The result of bitwise XOR operator is 1 if the corresponding bits of two operands are opposite. That is, it is 1 only if it is 0 and 1 or 1 and 0. If it is 0, 0 or 1 and 1, which it will result in 0. Now for the same example, you take 0, 1, opposite, so 1, 0, 0, same, so 0, 1, 0, opposite, hence 1, 1, 1, same, so 0, 0, 1, opposite, so 1, 0, 0, 0, 0, 0 will give 0, which is equal to 21 in decimal. Next, we have the bitwise complement operator. Bitwise complement operator is a unary operator, which means it works only on one operand. It changes 1 to 0 and 0 to 1. It is denoted by tilde. Now we take another example, 35. This is the value in binary. Now the bitwise complement of 35 will be 1 will become 0, 1 will become 0, 0 will become 1, 0 will become 1, and so on, which is equal to 220 in decimal. Shift operators are of two types, left shift and right shift. First, left shift operator. The left shift operator shifts all the bits towards left by a certain number of specified bits. Now the bits position that have been vacated are filled with 0. Let us take an example here. 212, this is the binary value. So 212 left shift 1, so it is shifted by 1 position. Here this 1 is discarded, so remaining is 1010100, that you can see till here. Remaining is filled by 0. You can see the 0 in the end that has been added. Next, 212 left shift of 0, shifted by 0 positions, so it remains the same, no change. Then right shift operator. Right shift operator shifts all the bits towards right by certain number of specified bits. Same example, 212 right shift by 2. So it is the certain number of specified bits by which it is shifted is 2. So you can see this. 0 is discarded. This 0 is discarded. So it will start from here. So 110101, 110101 filled by 0. Then left shift by 7. So you can see here. This is discarded, discarded, third discarded, fourth discarded, fifth shifted, sixth shifted, seventh discarded. So it starts from here. So 1. The rest all are filled by 0. Now here is an example of bitwise operators. We have got the same values. So results are also same. Bitwise AND will give 8, bitwise OR will give 29, XOR 21. Then right shift by 0, 1, 2. Left shift also. Here we have used loops. Right shift and left shift from 0 to 2. So many positions are shifted. The last operator, that is the conditional operator. The conditional operator is of the form expression 1, question mark, expression 2, colon, expression 3. Here, expression 1 is the condition to be evaluated. If the condition, that is expression 1, is true, then we will execute and return the result of expression 2. Otherwise, if the condition expression 1 is false, then we will execute and return the result of expression 3. Hence, we may replace the use of if-else statements with conditional operators. Here we have taken a simple example for conditional operator where A is 3 and B is 10. So now the condition is A is greater than B. 3 is greater than 10. False. Hence, what should we execute? B, because that is the false statement. Yes, so B has been executed. Thank you and hope you had a good time learning.